Good morning, guys. First of all, I would like to say Happy Diwali to all of you, and hope you enjoy your day. And welcome to the third video lecture on convolution codes. Last two lectures we have discussed about the basic structure of convolution code encoder, and then encoding the given message sequence using a time domain approach. In time domain approach, we learnt about how to write the generator sequences and then performing convolution to get the corresponding outputs and then writing the final output sequence. Okay, so this lecture we are going to learn about transform domain approach. Okay, so transform domain approach. So as the name says, in signal system we have studied that convolution in time domain is equivalent to multiplication in frequency domain. Okay, so multiplication is a lot easier than convolution in time domain. So in convolutional encoding also we do apply a transform in such a way that the message sequence and the generator sequences can be expressed as polynomials as a function of the delay parameter. So once we express the given message sequence and the generator sequence as polynomials, then we can perform multiplication, modulo 2 multiplication, in order to get the corresponding output sequences. Okay, for this transform domain approach also we will consider the same example. So that means the encoder what we discussed earlier, so the same encoder. So rate 1/2, constraint length k equal to 3 encoder. Output, this is the switch, this is the output, this is the input. Okay, so in this case we are having two generator sequences, but in general if you are having generator sequence, two generator sequences. Okay, so the first step in transform domain approach is express the generator sequences as polynomials as a function of unit delay parameter. D. So a single memory element gives a unit delay. So that is the reason why we need to express the generator sequences as a function of unit delay parameter. So let us say in general the generator sequence is given by, for the first output is given by G0 of 1, Z1 of 1, G2 of 1, and so on, Gm of 1. So let us say this is the generator sequence in general for a convolution encoder with two outputs. So this generator sequence corresponds to the first output. So knowing this generator sequence, we need to express this as a polynomial, so as a function of unit delay parameter d. So this is the generator polynomial for the first output, so which is equal to Z0 of 1 d power 0, Z1 of 1 d power 1, G2 of 2 d power 2, and so on, plus Gm of 1 d power m. So if you are having a generator sequence corresponding to a particular output of a convolution encoder, the first thing we need to do is express that in terms of as a polynomial. And if you look at this polynomial, the coefficients are the elements of the generator sequence. Okay, so similarly if we have a second output, that means second adder output, the generator sequence is z0 of 2, g1 of 2, g2 of 2, and so on, gm of 2. We need to express this also as a polynomial. So g2 of d is equal to g0 of 2 d power 0, z1 of 2 d power 1, g2 of 2 d square. Sorry, here I have written g2 of 2, g2 of 1. So g2 of 2 d square plus and so on plus gm of 2 d power m. Okay, so express the generator sequences as a polynomial. That means the polynomial is a function of the unit delay parameter d, and the coefficients of the generator polynomial are nothing but the elements of the generator sequences. Okay, so once we, this is the first point. Second point, express the given message sequence as a polynomial. Because we need to do multiplication, we need to express the message sequence also as a polynomial. So let us say in general the message sequence is given by m0, m1, m2 and so on, ml minus 1, where L is the length of the message sequence. Okay, now express this as a polynomial, again as a function of d. So m0 d power 0, m1 d power 1, m2 d power 2 and so on, m plus ml minus 1 d power l minus 1. So express the message sequence as a polynomial. Now after expressing the message sequence and the generator sequence as polynomials, next the third step. So assume that there are two outputs for the convolutional encoder. The first output is obtained by x1 of d. This is the first output as a polynomial, is given by m of d multiplied by g1 of d. So the first output of the convolutional encoder is obtained by multiplying m of d, the message polynomial, with the first generator polynomial. Okay, so once we have the answer for the first output polynomial, we can write down the corresponding bits by observing the coefficients of the polynomial. Okay, similarly the second output is given by x2 of d is equal to m of d multiplied by g2 of d. So once we get the two outputs, and if we write down the output bits from the two output polynomials, then we can obtain the final output sequence, that is the encoded sequence for the given message vector. Okay, so these are the 3 points in your transform domain approach. The first point is express the generator sequence as a polynomials. So if you are having two generator polynomials, express both of them in as a polynomial, then express the given message sequence as a polynomial, then compute the two output polynomials. In this case we are having two outputs, so we are computing two output polynomials. From the output polynomials we need to write down the sequences. So once we write down the two output sequences, we can write down the final output sequence by taking one bit from the first output, one bit from the second output. So in this way we can encode the given message sequence using transform domain approach. Now let us see the example. Okay, now so let us consider the previous example. So for the rate 1/2, capital K equal to 3, convolutional encoder, so we will be encoding the message sequence 100 11. This is the message sequence. And from the previous discussion, the encoder is having two outputs and the two generator sequences. The first step, the generator sequences are g of 1 is, which is z0 of 1, g1 of 1, g2 of 1, which is equal to 1 comma 1 comma 1. So express this as a polynomial. So g1 of d is equal to 1 into d power 0 plus 1 into d power 1, 1 into d square, which is equal to 1 plus d square. So that is the first generator polynomial. And we have g of 2 is equal to z0 of 2 comma g2 of 2, sorry, g1 of 2 comma g2 of 2, so which is 1 0 1. So this is the second generator sequence what we are having, and the corresponding generator polynomial is z2 of d is equal to 1 d power 0 plus 0 d power 1 plus 1 d square, which is equal to 1 plus d square. So we got the two generator polynomials. So first generator polynomial is 1 plus d square. Second generator polynomial is 1 plus d square. Now second step. So express the message sequence as a polynomial. What is the given message? M is equal to 1 0 0 1 1. So the polynomial is 1 d power 0, 0 d power 1, 0 d square plus 1 d cube plus 1 d power 4. So the message sequence is 1 plus d cube plus d power 4. So that is the given message sequence. Now third step. So obtain the two outputs. x1 of d. Okay, so x1 of d is obtained by multiplying m of d with g1 of d. So we got m of d is equal to 1 plus d cube plus d power 4 multiplied by, and g1 of d we got 1 plus d square. So this is our g1 of d. So multiply. So first term with the three terms, 1 plus d square. Second term with the three terms, d cube, d power 4, d power 5, plus third term with the three terms, d power 4, d power 5 and d power 6. So now 1 plus d power 1 we are having only one term, so write down. D square we are having only one term, write down. D cube we are having only one term. Next d power 4 we are having 2 here and here, that is 1 plus 1. Next d power 5 we are having 2, d power 5, 1 plus 1, and d power 6 we are having only 1. So which is equal to 1 plus d square plus d cube plus. So remember we are doing modulo 2 addition here. So whenever you see d power 4 plus d power 4, it is simply equal to 0. So if you take d power 4 common here, 1 plus 1 modulo 2 addition is 0. Similarly d power 5 we are having two terms, d power 5 common, and so 1 plus 1, so 1 plus 1 modulo 2 addition is 0. So these two terms will be 0 and we will be left with d power 6. Okay, so now the first output polynomial is 1 plus d square plus d cube plus d power 6. Okay, so in a similar fashion, so find out the second output polynomial. So x2 of d is equal to m of t into g2 2 of d, which is equal to 1 plus d cube plus d power 4 multiplied by 1 plus d square. So this is the second output sequence. So if you multiply these two, first term, so 1 plus d square, second term d cube plus d power 5, third term d power 4 plus d power 6. So here we are having 1 plus d square, d cube, d power 4, d power 5, d power 6. So this is your x2 of d. So this is your x1 of d and this is your x2 of d, the two output polynomials. Okay, now express these two polynomials as sequences. So how to write down the sequences? So look at the coefficients of the unit delay parameter. Now for the first output polynomial, 1 means this is the coefficient of d power 0. Okay, so the sequence x of 1 is, so in this polynomial d power 0 coefficient is 1, so 1, d power 1 coefficient is 1, so 1, d square coefficient is 1, d cube coefficient is 1, and we don't have d power 4 coefficient and d power 5 coefficient, so d power 4 coefficient is 0, d power 5 coefficient is 0, and d power 6 coefficient is 1. So this is the first output sequence. Similarly, the second output sequence x of 2, d power 0 coefficient 1, d power 1 coefficient we don't have it, so 0, d square coefficient 1, d cube coefficient 1, d power 4 coefficient 1, d power 5 coefficient, d power 6 coefficient. Okay, right? So these are the two output sequences, and if you are having the two output sequences and we know how to write in the final sequence, so the final output encoded sequence is x, which is 1 bit from the first output, 1 bit from the second output, so 1 1 comma, again 1 bit from the first output, 1 bit from the second output, 1 0, and next 1 1, and next 1 1, next 0 1, next 0 1, next 1 1. So if you check this answer, this is the same as what we got in the time domain approach. Okay, right? So in this way we can perform encoding process of the given convolutional encoder using the transform domain approach. Okay, so let me summarize. So for the given convolution encoder, write down the generator sequences, and then after writing the generator sequences, write down the generator polynomials as a function of d. So after writing the generator polynomials, the next thing we have to do is take the message sequence and express this as the polynomial. To obtain the first output, multiply the message polynomial with the first generator polynomial, and remember, while performing multiplication it has to be modulo 2 multiplication, and when you are having two terms as a common, then you have to go for modulo 2 addition. Okay, so similarly compute the second output polynomial. So once you got the two output polynomials, you need to express them as the sequences. So how to write down the sequences? Observe the coefficients of the unit delay parameters. So d power 0 to d power 6 in this case. Okay, so write down the coefficients, you will get the output sequences x of 1 and x of 2. So once you get the two output sequences, write down the final output sequence by multiplexing the two output sequences. So multiplexing means 1 bit from the first output, 1 bit from the second output. So in this way we can perform encoding process using transform domain approach. Okay, so hope you understood. Thank you.